starting the recording, and I'm immediately going to start talking about where we are in our lecture series. Let's just wait for it. I just want to quickly show you, as soon as the screen appears, where we are in our code. Right. So let me just get to this practical test preparation section, and then I'm going to edit. No, man, edit. Okay, let's just give it some time. Right, there it is, maximize. Perfect. So yesterday we finished our output function. So there's our output world function, and that is exactly where, well, here we go. This was the function that actually did the whole output thing, but we haven't implemented it yet in our code. So without further ado, I'm just going to immediately start doing it, so that before we actually continue, we actually get this out of the way. Right, it's called a function that will output the game world. Just before that, I just want to quickly clear the screen. Now, on the VPL, we use the command clear because it's a Linux-based environment, so that's why we use clear. And then I'm just going to quickly output a menu option here. Now, there's not much in this game that requires some input, so I'm just going to say P is the next round, and then what else should we have? Q for quit, maybe. And for now, that's it. And then I'm just going to read something in. Otherwise, this thing is going to loop the whole time. And then let's see if our program actually compiles and runs. Okay, let's have a look. All right, so there we go. It's a little bit small on your screens, probably. I wonder if I can make it bigger. Not sure. But anyway, so there's a bunch of characters. Those with the stars, they are the infected characters. Those that's R is recovered. S is the susceptible characters. And then we're going to press the P button to get to the next round, and Q is going to quit. All right, so that's where we are at the moment. Next step is we're going to handle the character movements from, well, we're going to handle that. So let's have a look at the actual requirements. So firstly, it says that each character independently moves one step in any random direction, including diagonals. It is also possible for characters to stay still. Characters may not leave the environment, and characters may not move into each other. Okay, so let's see if we can manage that. The way that I'm going to handle this, and I'm going to use Excel to try and describe my solution, is let's consider this two-dimensional array world. So there you can see that we have a character. Now, potentially, we can move into any of these 8 directions. And the way that I'm going to determine in which direction my character will move is I'm going to just generate a random number between 1 and 8. So rand between 1 and 8. So if this was our program, boom, my character would have moved into that location. All right, because that's what 1 means. Now, one thing which you have to be aware of, so let's just stop this quickly, is consider a case where my character is there. So that's currently in 0, 1, 2, 3, 4, and 5, and that is 0, 1, 2, 3. Let's just make here as well, 0, 1, 2, 3. Okay. Right, so let's assume this character, or we're going to move the character, we're going in our movement function. One approach in which to handle the movement is to create a little nested for loop and then effectively iterate through each cell in the game world. So effectively, we'll start in the top left cell, then we'll see, is there a character there? Then we'll handle the movement. Then we'll go to the next cell. If there's a character there, we'll handle the movement. Then to the next cell, a character there, handle the movement, etc., etc. So what shall we do? We just say, let's say identify cell, or yeah, let's say identify cell for lack of a better word. If character, then move character. That's effectively the iteration that we're going to do. We're going to iterate through these steps the whole time. From identify cell, basically just go to the next cell. So go to next cell. That's maybe a better one. Now the problem is the following. So let's assume this specific case, 0 and 0. So let's say, for instance, we randomly generate a direction that the character has to move, and let's say, for instance, we see that the character has to move into the next cell. So if the character, we found the character, did we move the character? Yes, we moved the character, and we moved the character into the next cell. Right? Remember that this is the cell that is still active. Now we finished with this cell, and we go to the next cell. And we again run our little algorithm. Okay, is this a character? Oh, yes, it is. Well, move the character, and potentially we can again move the character to the next cell. Now, hopefully you understand that that is a problem, because in one round, the character is not supposed to be able to move like 200 paces, because that's effectively what can happen. This thing can move all the way to the right-hand side, and eventually, if the thing gets to a certain section, then the characters can get too many movements effectively. That's what we're trying to stop. So one thing which we can do is to consider and implement the solution the following way. So what we have is we've got, let's call it a static world, and we've got an updated world. The updated one is just temporarily there, or you can mix it around. Doesn't really matter, in fact, which way you put it around. Let's assume this one is empty and there's nothing in there. If we then move a character, we don't physically move it in the static world for now. We only move it in the updated world. So if we start with the cell, we decide that the character has to move to the next location. What we do is we actually put the character in our updated array in the next location. That then helps so that if we now move to the next cell, that we don't unduly move the same character again. All right, and that also helps to eventually, if we, for instance, get to this location, so let's say, for instance, that location also has a character, and that is now the active cell, and this character wants to move to the left. We must evaluate not the static cell or the static array to see if we can move left. We have to look at the updated array to see if the character can move into that location. If the character cannot move into that location, meaning there's another character there already, then we have to generate another movement function or a movement selection so that it can potentially move. Or we can just leave the character in its same location. All right, so that's the principle. So we're going to have to make use of this temporary array. Once we've worked through the whole array, then we're going to take this temporary array and we're going to make this the active one. So we're going to copy all the values that's in this array back to the static array, and then we're going to delete the updated array. All right, so that's one of the things that we're going to do in this specific lecture. Let's see if we can actually start to get this thing running. Now, the first thing that we can do to help us with this random location is to create a few consts. Let's say random, or let's say movement directions. Then let's create a few here. Let's say it's up left, is, what did we say, it's 1, 2, okay, so we've got a few here. Let's see, 2, 3, 4, 5, 6, 7. We need one more. Okay, so there's 8. So that was up left. This one was up. This one is up right. And then this will be right. This will be down right. And then this will be down. This will be down left. And then this will be left. Okay, so this is going to help us a little bit with that movement, and we don't have to remember the numbers. Okay, good. Let's start with our function prototype. So I'm just going to say move characters. And I'm going to say it's a type 2 array that I'm going to have in there. Okay, let's have a look. Someone has a hand up, or there's something like lacquer. So, sir, are you correcting when we press no? It's got. Remember, these characters don't take our input in. We don't handle their movement, Mr. Sabanda. They are going to be randomly moved. So we don't press D D D D D D D. We're going to press P a number of times, and then they will keep on updating. Okay. So and that's not what we're doing here. Okay. Const int. Yeah. Int. What's int? Okay. Then I'm. Yeah, it's probably int. Okay, probably made a mistake here. And yeah, it's supposed to be int. Insert. There we go. And save and bold. Let's see if I made this. I'm still busy here. So type 2 array, let's get the number of rows in here and the number of columns. And I think from now, that might be it. We'll see now if that is enough parameters or not. Okay, I just want to save. Just want to bold. If there's any. Okay, that's all good. Right, so the first thing now is int direction is get rand, and this will be from up left to left. That is the directions that I wonder if it will work. Let's see if this is going to work. It's supposed to, because this is just integer values. So let's see, up left to left. Yeah, it should supposed to work. So that is supposed to generate a random number between those 8 directions, and it will put it inside this specific variable. But I'm not going to do this right now. In fact, because I need this per character that I move. So I'm just going to park that. So let's just quickly get our little loop going here. Int rows. Okay. Right. Let's have a look for our columns. Well, columns they stand into columns. Columns plus. Okay. So if array world character is not equal. So if it's not empty, then I know I've got a character here. Anyone, doesn't really matter what it is. Okay, so basically I found a character. See if the cell contains a character. Get a random movement. I'm just thinking, I think it might be worth my while. No, not yet. Let's just park here. I'm going to do the move the character here. If a valid move, then move character. Well, I'll handle that all in one go. Okay, but before I can do this, remember I said we're going to need this temporary array or this temporary world that we're going to put our stuff in because we're going to evaluate this to see whether there's a character, and then any changes that we're going to make will be in the other two-dimensional array. So let's create our two-dimensional array here. And we're going to say, I'm just going to call it array temp. The problem is array temp needs to be allocated memory. And if we look at our init world function, we actually have the code that does the memory allocation in here, but we've got this stuff mixed up as well, which actually puts some values in there. So I'm going to take some of this code out, and I'm going to handle the allocation of memory separately. Well, actually, doesn't really matter. I can put everything, I can basically initialize everything to empty, no problem, because even in my temporary array, everything can be by default can be empty. So I'm going to create a little function here, and this function will also return a two-dimensional array. And I'm going to say allocate memory. And this thing will create a two-dimensional array. I'm just going to say array nums. No, let's take exactly the same code, otherwise I'm going to have to retype things. And I can just take this whole thing and just use it as is. And then return it. A world. Then I'm going to replace all of this, well, not all of it, basically that is equal to allocate memory int rows int columns. Okay, so that will allocate memory for my normal initialization, and it should work. And I can use it here then as well. So it's equal to allocate memory int rows int columns. Okay. I call it allocate memory, alloc memory. Yes, I did. Okay, let's save. Let's see if there's any syntax errors, because that's quite a major difference. Okay, that looks all good. Good. So now I've allocated memory for my temporary array, but now I don't have to make copies of it yet. Eventually, I'm going to have to make a copy of it, but I'll leave that for a little bit later. Now, let's see if we're going to move the character. Do I want to make a separate function for that? I'm just thinking. We'll see. There's no reason really, so I'm just going to move it in here. Let's make it a separate function, I think. And this one is a move character, not characters. So I'm going to take in my two-dimensional array. What did I do just now? Huh? What did I do now? Okay, hopefully everything is still fine. Type to array world. I wonder if that's really necessary. Probably not. Then I need type to array. Yeah, I'm probably not going to need the original array world, so I'm just going to call it array temp. I'll see now. I need to know the number of rows, the number of columns. I need to know the row and the column that we are interested in. Okay, so okay, stop. That indicates this is our code for today. For the late viewing register, it's VLR322. So just repeat, late viewing register code VLR322. Perfect, let's get that out of the way. Okay, so now we're going to generate a random number, which is the one that I have here at the bottom. Good, and then I'm going to evaluate that correction. Case, and then up left. And escape. Right, I also need a destination row, int destination row potentially, and let's make that the same as the current row, and the destination column, which is int column for now. So for up left, let's just finish the code here. If I move up left, then the destination row will decrement, and the destination column will also decrement, because I've up is the row just above it, and up left is the column just left of it, and then we will break. If I'm just going to move up, then it is just destination row will decrement. If I move up right, it will be the nearly this thing, but the destination column will increment. Okay, if I move right, then the int destination column will increment. If I move down right, then that will increment, and the destination row will also increment. Let's move down, and the destination row increments. If I move down left, then the destination row, well, let's take this one. Save me some typing. The destination row increments, but the columns decrement. If I move left, I already have up left. Yes, I did. So that one is not necessary. Then int destination column decrements. So this will help me to calculate this potential destination. Now, okay, I'll worry about what's going to happen now. Calculate potential destination. If the destination is not in the world, so that's another thing. So let's get a little Boolean function here. Is in world. So you see is in world. No, I don't have is in world. I'm going to create an is in world function here. Int rows, int columns, int row, and int column. Right, and then return following statement: int row greater than or equal to 0, and int row less than int rows, and column greater than or equal to 0, and int column less than int columns. There we go. If is in world, then I can potentially move the guy, which is int destination row, no, int rows, int columns, int destination row, int destination column. Okay, so that's the first check that I have to do. And then I also need to check that the potential destination doesn't already contain a character. So for that, I'm going to evaluate. So this is just my array temp, my temporary array. So if array temp int destination row, int destination column, is not equal to empty, then, or rather, if it is equal to empty, then I know I can move it. Okay, so if the destination is empty, then move the character. All right, so what we're going to do is we're going to take whatever value is currently in the normal player row, the row where the player is currently at, and I don't know what that is, so that's why I have to have the normal array here. Type to array world. So we need to know what value that is. So let's do this. Array world, array temp. Int destination row. Int destination column. This will now be the same value as array world, but int row and int column. So whatever value we came from, this is the value that we're going to store it in. If it's not in the world, well, if the value is not empty, then the temporary array, well, hold on, is there maybe a better way of doing it? No, let's just do it this way. So the destination row, let's just do this. So that will be the same. So if we couldn't move into that location, and I'm just going to copy that character into the destination section. The same happens if it wasn't in the world, then I'm going to do the same. So that basically keeps the player exactly in the same location, but I have to update the temporary array. Remember, the temporary array by default is empty. There's nothing in there. So that's why I have to look at it. In fact, I cannot evaluate that. That is array world. I have to evaluate whether, no, I have to evaluate the temp. That's correct. All right. Good. That should do that. Let's see if we save. Okay, that's all. No, there's a few errors. What was that error? Let me see. Oh, there's a spelling mistake. Type to array. Let's try that again. Okay, that's all good. Now let's move the character. I'm giving it the array, the temporary array, the total number of rows, the total number of columns. But this is R, that is C, row and column. Okay, that should move it. Now, once we've moved it, I have to now copy the temp array into the normal array, into the array world. I'm going to create a little function that will do that copying for me. Copy array, type to array 2, and well, just like that, I think. Type to array from, and I need to know the total number of rows and columns. Okay, for int r 0 while r less than int rows. I'll look at the questions just now, guys. Just give me a sec. Let's see if I can get most of this code right. Let's see, less than int columns, plus, right, now, array 2, row column is equal array from row column. Okay, so that should copy the array. And that is from the temp array into the array world. Comma rows into columns. Right, and then once I've done this, I have to deallocate the memory. I did not create such a function yet. Okay, I'll have to do that as well, but let's first see if we... So guys, remember to press the save button. That's quite important. So when you're writing your semester test, press the save button quite often so that your code gets saved onto the VPL. Next is I'm going to have to deallocate memory, and I'm going to create an actual prototype for that. So dealloc. The reason is that I'm going to use this from the main function as well. And I just need the number of rows. And of course, pass this by reference. So for int row 0 while row less than int rows r++, boom, delete array world r. Once you've done that, delete the array world, and then array world is null pointer. Save. Okay, no compile errors. Okay, so now deallocate. And this is array temp, my int rows. If you don't delete the temporary array that you've just created, it will create what they call a memory leak, and you're going to have some trouble. So let's see, move characters. This is what's going to happen here. World. In fact, let's do this. And I know I'm not going to make a mistake. Array world, number of rows, and the number of columns. Okay. Right, save. Hold and run. Let's see if there's any syntax errors. Okay, well, so far so good. Shall we try the next round? Did things move there? Looks like, yeah, looks like things are moving. Okay, we'll look at details just now. I'm not sure if you guys could have seen that. Let's first get and see if there's any questions. Okay, let's start at the top. Okay, so there was the integer. Sir, is update function always called or only called when a movement should take? So, sir, is the update function always called or only called when a movement should take place? Okay, I haven't done an update function. Well, it's kind of an update here because we don't really do movement that's initiated by the user itself, meaning the user don't decide how things are moving. So in this case, it's still an update. So I'm not sure exactly what you're referring to here, but I'm following the same, let's say, logic that the actual instructions have. So the movement is all in the same place, and then we're going to have to handle the update, which is separate logic, and that's why I'm also implementing it this way, separately. So I'm first handling the movement of the users or the characters, and then I'm going to have to handle the updating of the health and all of these things. So for now, just the movement, and that's why I have it there, but it's kind of like updating the status of the world anyway. So let's see what's the other question. Am I the only one who can't see the screen? Reload, refresh. I think you could include a condition in the updated world or have a condition to trigger the updated world. Okay. I think you hit the Control T, sir. Oh, that's probably it. I don't know. I don't know what I hit. So how would the approach be if you were to place the different directions within the randomizer function with the lower value, the lowest identifier of the movement, and the higher value of the highest identifier of the movement? Well, that's exactly what I did. So Mr. Libaka, this is exactly what I did. I actually used, maybe you saw that, the random get random function. So here it is. Where was it? Here on top. I used up left and left. Up left was the lowest value, and left was the highest value. So that's exactly what I did. The condition can test movements, whether it's in the update function or trippers the updated function. Okay, I'm not sure what the question is. Sir, must we do error checking with error range? You must do some kind of error checking in your programs, please. So you must have some places where you do some kind of checking for ranges, perhaps checking for whether characters were successfully converted to integers. You must have those because you actually get marks for that. So whether you trigger the update, always update and evaluate the condition within the update doesn't matter. Okay. So does the order of the functions in our library make a difference? Yes and no. So if you declare a function in with what they call a prototype in your header file, these prototypes will be declared always on top of any kind of file, because that's in fact what the include does. So if you look at include libmodel.h there on top, it actually copies and pastes this text. So this text actually tells the system that, hey, we have these functions and we're going to use this function. As soon as that happens, it doesn't matter in which order those functions, these specific ones, 1, 2, 3, 4, 5, these 5 that I currently have in the H file, where they appear inside your implementation file. However, it does matter for helper functions. So for instance, the getRand function, if the getRand function wasn't declared before I actually want to use it, then the compiler will fail. So that's why getRand has to be above, for instance, the move character function. That's why if I scroll up, you'll see that getRand is here. And normally I try to place things like getRand quite high because a lot of my functions actually use that. Okay, so yes, it does matter, and sometimes it doesn't matter. It depends. If we do get the get into error checking without the error range, is there a problem? If we do get the get into without the error range, is there a problem? I'm not sure what's being asked. So is there a problem? Sorry, you'll have to restate that, please. Okay. I think it would be better to have the condition trigger. Okay, there's still things that I don't understand. Will int row still increment if we use int row plus 1? Yes, it will, but obviously your syntax will be a little bit different. You can't just do int row plus 1. You'll have to say int row is equal to int row plus 1. I just use shorthand here because int row plus plus is a little bit shorter. You could have done int row plus equals 1. That will also increment it by 1. So when you're explaining about the static and the updated environment, was that figuratively or literal? Does our program have 2 environments, or you were explaining the concept of movement? In my example here, I physically have 2 environments, but only temporarily. So if you look at this section, remember, when I'm in my move characters, I actually create a second environment here. I create a second 2-dimensional array, and that is my, let's call it the world that I'm going to update in. And then I actually use that 2-dimensional array to move my characters in, and then later on I actually copy it. Don't we need to find the player first? In this example, there's no player, Mr. Mill. They're all just characters. There's no player in this example, so there's just a bunch of characters that's on screen that randomly moves. Okay, I hear you. Thanks for that. Okay, sir, please can you explain again why you are using a destination? Well, you need to know where you're moving into, and that is called a destination. So, for instance, if we need to know where we have to calculate the destination cell that I'm going to move into. If you don't have a destination, then there's no way to know where you're going to have to move into. The problem is you can't just change into row and into column, because you need to know also where you're coming from. So you need to know where you're coming from, and you need to know where you're going to. Because otherwise, if you don't know where you're going to, then things such as is in world will not function properly. For instance, is the destination row and destination column in the world? If they're in the world, then we can move. If they're not in the world, then we're keeping our character in exactly the same location. But obviously, well, this is exactly what I'm doing here. It's in exactly the same location, and that's why we need a destination variable. So we need actually two types. We need to know where we're coming from, so that we can take the character from where we're coming from and putting it into the place where we're moving to. Yes, semester test is next week. Yes. Tough times last time. Okay. So I've been wanting to ask, why do we only include the rows when deallocating memory? Please have a look at the lecture where I covered, where we reviewed the allocation, but effectively, no, I don't think I actually did that. Let's see if I can quickly do that. Right, so I'm going to quickly just paint the picture again. So what we have is we've got some kind of array world variable that is a pointer type. This pointer type points to an array of pointers. So boom, right, and maybe something like that. And that array of pointers potentially points to a two-dimensional array. So this is, let's make that a yellow color. Oh no, let's make that red. I think that's what we had the color last time. I think that was a blue color or a yellow color, and then this was blue, I think, to have the actual ints. Right now, what you see there is actually declared as that. All right, and what you see there, the red one, let's make it a nice blue, so that, okay, the red one is declared as that. All right, now when we deallocate, we first go into each of these guys, and that is only the number of rows. So we go into this little guy. So when we say, so if I do a little for loop here for int r0 while r less than int rows, r plus plus, whatever, delete everything that belongs to array world r. Did I actually implement it correctly? And then afterwards, delete array world. Okay, so what happens with this line of code is you're going to each of the rows, and then you're going to array world r, which is effectively that little pointer there. And you're going to say, hey, little pointer, you are not pointing to that memory anymore. In fact, go and delete that memory. So what's going to happen is as soon as you delete it, this memory is given back to the operating system. Then it goes to the next one, and it deletes all that memory. That's what the delete function does. The delete actually goes and deletes all of the values associated with that pointer, and that pointer is that specific yellow guy. And then the last one, that delete, basically goes to this guy and say, go and delete array world, which then takes that and deletes that memory and deallocates that. Right, but I just want to double check and see if I implemented that correctly. If something tells me that I made a mistake, no, it's correct. Sir, why did you make a temporary array when moving the function? I did that. I covered that in the beginning. I tried to explain what happens if you just move the character. So please just watch the beginning of the lecture. Can the temporary array be considered a sandbox? Absolutely, it's like a sandbox. It's I normally call it I normally call one the static world and the other one the active world or things like that. So you're 100% correct. It can be considered as a sandbox. Is a random function there in the header file? No, it's not. So is it better idea to have all the helper functions above all the functions in our created CPP? Yeah, that's a good idea. I asked if we do our error checking, getInt and do not use error range is, okay, getInt is a function that probably will translate, is there a problem or must we have both together? Okay, we want to see that you've done some, whether you've implemented at least more than one place of what we call traditional error checking. Okay, so if you only do error checking in one place in the function and nowhere else, then that's not good enough. At least more than once, please. So isn't the yellow ones that are in star? Let's see, what did I have it? Well, yes, it was in star. You're 100% right. Yeah, sorry. Can you see that? Okay, it's a horrible color, but you're 100% right. So yes, you're absolutely right. It's not the blue ones. It was in fact ints. So let's make that a different color. So let's just paint the picture again. But I'm going to give that a different color so that we can actually see it a little bit better. That was blue. Is our time up? Our time is up, guys. So that's actually what it was supposed to look like. So yes, you were 100% correct. In star was in this now green. Yes. Okay. So that is the final explanation of how a two-dimensional array and all the different types actually looks and works. Right. Must we have both together? Why is the random function not there in the header file? Because I don't use it in my main function. You only need to put functions in the header file if you use it outside the implementation. Do we not set the rows to null when deallocating? No, you don't set the rows to null. No, just deallocate it. Because it's a helper function. Okay. Why do you use null pointer? Because that is modern C++ 11 standards. Okay, guys, I think our time is up, so I'm going to stop sharing